Today in class we talked about what it means to design a fair game, and particularly we talked about how to create tree diagrams to show all possible outcomes and then think about what are the theoretical probabilities in those outcomes. For homework you're going to work on page 4. Make sure you've had a chance to complete those before you correct them. In question 1 we're being asked if tossing 3 coins is the same thing as tossing 1 coin 3 times. Well, for Patricia here you might think about if I toss 3 coins. My first coin, I can get heads or tails. My second coin, I can also get heads or tails. It's my first coin, my second coin, and my third coin is going to come off of that. And so if I look at all this, I can now compare it to the other situation. So again, this is first coin, second coin, third coin. Jean now says, what if I take 1 coin and toss it 3 times? So here I am tossing it the first time, then I'm tossing it the second time, and here I am tossing the coin the third time. So what do you notice about these two tree diagrams? Well, 1 coin, 2 coins, 3 coins, 1 toss, 2 tosses, 3 tosses of the same coin, we get the same possible outcomes. Now for the second problem, we're being asked if these two people are equally likely to win. And so Ava's going to get a point if there's no consecutive toss results that match. So for example, she gets a point for the outcome. And actually it probably makes sense if you haven't to list all the possible outcomes. So let me do that really quickly first. So heads, heads, heads. Again, I'm just tracing the outcome here on the trees. Then I have heads, heads, tails. Then I have heads, tails, heads. And you can kind of see the pattern here, just like we did in class. I'm going to just keep listing them. Heads, tails, tails. Tails, heads, tails. Tails, heads, heads. Tails, tails, tails. Tails, tails, heads. And so those are my 8 possible outcomes for both of these situations. And so Ava gets a point if there's not consecutive toss results matching. So I can't have 2 of the same letter in the row. So for example, heads, tails, heads, those are not consecutive, so she'd get a point there. She'd also get a point for tails, heads, tails. Then we have our other person, Pietro, and Pietro is going to get a point if there are consecutive results. So for example, heads, heads, tails, or heads, tails, tails, or tails, heads, heads, or tails, tails, heads, right? All of those have consecutive tosses in them, so some of them, the matching letters, right, in a row. And then finally, if we get a tie, we are going to toss again. So thinking about Eva here, she has 2 out of 8 chances to win. There's 8 possible outcomes and she can win 2 ways. Pietro can win 4 ways out of the 8. And we also know that if you get heads, 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 or tails, 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 you're going to go again. So 2 out of the 8 ways are going to result in having to retoss. So are these fair? Is this a fair game to play? Well, looking at this, Pietro's chance, 4 out of 8, that's 50%. Ava's chance, 2 out of 8 is 25%. This doesn't seem like a very fair game. So one of the things we could possibly suggest is that maybe Pietro switches here. Maybe he only wins if he gets a match instead of the consecutive numbers. That would be one possibility. Another thing you could suggest is that Eva wins if she gets either non-consecutive tosses or matching, because that would be 4 out of 8 as a chance. So however you suggested you change the rules, make sure that now they both have the same chance of winning each time they play. What are all the outcomes for the sums? Well, I could get an odd plus an odd, and that would give me an even sum. I could get an odd and an even, which would give me an odd sum. I could get an even and an odd, which would give me an odd sum, and an even, which would give me an even sum. What would be some rules for a game that's fair? Well, I could tell someone that they get a point if they get an odd sum or an even sum. So for example, maybe Sylvia gets a point if there's an odd sum, Juanita gets a point if there's an even sum. They both have the same chances of winning, 2 out of 4, so I know that that's a fair game. What about a game that's not fair? Well, maybe I could say that Sylvia gets a point if she gets an odd sum, but maybe Juanita only gets a point if she gets an even sum with an odd number plus an odd number, for example. So maybe Juanita can only win 1 way out of the 4, Sylvia wins 2 ways out of the 4, and maybe an even plus an even results in a retoss. Somehow they should be unequal chances of winning. And how is this similar to tossing 2 coins and seeing if they match or don't match? Well, maybe you thought about how there's 4 possible outcomes. Another thing you could think about is that maybe originally it looked like there were only 3 possible outcomes when you didn't understand the difference between odd plus even and even plus odd as differences. We'll see you tomorrow.